So sniffing. Now sniffing is the process of eavesdropping on network traffic that is not bound for your own network interface. So you're trying to figure out what someone else is doing. Sitting where you're sitting, you want to remote into another machine and be able to figure out what they're doing. Now, you're really not remoting into another machine, you're really remoting into another network. Or you're looking at everything that's going through that network, between your network and that network, so that you can detect what's happening. Now, it requires the network card to be placed in what is known as promiscuous mode, so that you can detect and process all of the traffic on the network. The interesting thing is that this remote network connection, if you will, as this remote network connection can be yours, okay, that remote network connection is trying to figure out what's happening on your network. So you want to try and prevent whoever is over here from gaining access to your network to begin with. If they do not have access to be able to establish any kind of a connection to your network, there's no way someone else would be able to sniff anything. The fact of the matter is, this remote network connection can just be within your overall network altogether. So this remote network, if you will, can be your internal network. Now this is kind of interesting because in this case, or in this instance, your network can be your subnet, right? And remote network can be another subnet on a different floor. This is a way that you can sniff. Now, nothing says that you're going to be sniffing traffic that is not inside of your network at all. You can certainly sniff all kinds of traffic coming and going. As a matter of fact, very frequently, you will have a sniffer running so that you can detect everything that's going on in your network. It doesn't really matter if it's someone coming in from the outside or if it's someone that's trying to attack you from the inside. How do you really detect attacks? Sniffing is going to help you determine unusual traffic and unusual traffic patterns. If someone is trying to gain access to your network and a device on your network, and let's say they're trying to access a device on your network that is a Windows device, and they're trying to FTP into a Windows device that happens to be a Windows desktop, and this machine over here does not know that this is a Windows device and it is a Windows client device like Windows 7, Windows 8, or Windows 10, and they're trying to run a FTP client on this, you would know using sniffing tools that there's something fishy, if you will, going on over here. Right? So the other aspect is that the sniffers are a combination of software and hardware that are designed to capture network traffic right off of the network. Okay? Once they captured that network traffic, they're supposed to record it, analyze it, and categorize it. And this is done for both wired and wireless environments. And it is available for both Linux and Windows. Wireshark is one of the most popular sniffer products around, in addition to TCP dump, which is widely used in the Linux environment. I'm going to show you demonstrations so that you can see how Wireshark works and what kinds of things you can detect. Now, sniffing is very effective when you're dealing with clear text. You know, when you have a plain old HTTP or FTP, HTTP in port 80, FTP in port 21, Telnet, DNS, DHCP type traffic. Okay? Sniffing is not effective when the protocol is not clear text, such as SSH, SSL, secure socket layer, okay, secure shell, or IPsec. Okay? Because really you have to figure out what's going on in the traffic. Tools such as Wireshark will still give you all of the data that has been going across, except the data that's been going across would be encrypted. So you would have to take that additional measure that is usually very complicated, always very complicated with encrypted protocols, of being able to decrypt what's happening. Very, very, very hard to do. Now, one of the ways you can prevent someone else from sniffing your data is to use encryption-based protocols and switched networks. The idea is that you want to make sure that your network is protected. right? And that the remote network, even if they try to get in, you are able to detect via sniffing patterns and via sniffing data that someone is trying to gain access to your network when they really aren't supposed to, and that they are trying to do something on your network, on your machine, on your devices that is not intended for them. You can be very careful and you can be very well prepared for what's going on. And Wireshark and tools like that can help you do just that. So what I want to do here is I want to show you a demonstration of what it looks like when you are capturing data that is not well hidden and it is in clear text. The example that I'm going to use is the FTP server. I'm sitting on my CentOS Linux box. This is CentOS version 6.7 and I've got VSFTPD installed. So let me show you. If I do service VSFTPD status, you'll notice that that service is running. And VSFTPD is a very simple FTP server inside of the Linux environment. And if I do a less VSFTPD configuration file, I want to show you that I've enabled anonymous users. Not that that's a good thing. You're really not going to enable anonymous user access to your FTP server in the production level environment, but for my purposes I have. And I've enabled some other settings. For example, the default mask for the universal mask for local users is a 077. This is a global mask, and you can change it to 022, which is what I am sitting at, which is a default for FTP servers, or really for default universal mask for the Linux environment. Anyway, for the files, 022 simply means that you get file permissions of 644, which is read, write, read, read. And then some other settings that are listed here. The other thing that I did here is I created a banner out of the default settings here. I have a banner and I call it my FTP banner, which I'm just saying welcome to the demo FTP service. Okay. So nothing really strange there. And in my case, I have turned off SE Linux, which is, I guess, a preference of mine, but it depends on really which organization you work with, and if they have FTP running on it, they're probably going to have SE Linux enabled. And if you do have SE Linux enabled, you have to turn on FTP home directory option in SE Linux to allow for default home directory access to your machine. So I have disabled SE Linux, and the way I have done that is by going into the config, this file right over here, and I have disabled SE Linux right there. And once you disable SE Linux, you have to restart the machine. So I disabled SE Linux and I restarted the box. Now on this machine, FTP server is running. Now what I'm going to do is I'm going to log in as Rafiq, and in the etc, now I'm going to go to the home directory, in the home Rafiq directory, I can see that there is a data file, 0 bytes, but there's a data file that is not hidden. The other files over here are hidden. The data file is not. Also, Rafiq has a specific password that, I'm not going to tell you right now, because I'm going to use something called Wireshark, and I'm going to open up Wireshark. I'm going to do Wireshark scanning on a Windows box, which is going to serve as my remote machine, if you will. And I'm going to FTP into this FTP server and try to figure out what the password is for the Rafiq user, so that I'll be able to show you that FTP passing data in clear text, how it's so simple to be able to see the password that someone entered inside of FTP. All you have to do is really be monitoring it, utilizing a network monitor or a sniffer. In this case, I'm using Wireshark to accomplish that task. So let me take a look here on my Windows box. This is my Windows machine. I have Wireshark right over here. I'm going to open it up. All right, and there's Wireshark. And all I'm going to do is I'm going to click on Start right over here. Click. And I'm going to open up my command prompt, and I'm going to use the command prompt as my client. And I'm going to open up my FTP server. I'm going to log into it. There you go. And here's some data coming across, as you can see, on my Wireshark. Okay, so that's the acknowledgement that I got from 10.10.10.100, which is my Linux box. And I'm going to log in as Rafiq. And notice right here, request user Rafiq. Okay, now it's please specify the password. See it right here? Please specify the password. And I'm going to enter the password in. And when I enter the password in, look at that. There's a password right there. My secret password. Clear text. And it says login successful. So I know that this is the password that was entered in for the Rafiq user. And I'm able to go in now and, well, interrogate and really do whatever I want to do. If I choose, if I do an ls to do a listing, there's a data file right there. And I can do, let me move this up. If I do get data, okay, so we just transferred the data file as 0 bytes. Okay, and I'm able to get it. And I'm going to exit, quit. And when I minimize this, here I just exited, acknowledgement, transfer was finished. I quit, I did a goodbye, so everything is done. All right. Now I'm going to go over back to my Linux environment. And in my Linux environment, I'm going to change the password for Rafiq. So let's do this. I'm going to do here, and I'm going to say password for Rafiq is going to be different. I'm going to change this password to something else. Okay, so I just changed the password. I'm going to go back to my Windows environment into Wireshark. Here's my Windows environment. And let me stop this trace and let me just going to get out of this, exit, and quit without saving. Open up a brand new trace, and here it is, opening up a brand new trace. I'm going to click start, click on the command prompt, and I'm going to do FTP, and I'm going to do open 10.10.10.100, type in Rafiq, type in my new password, and look here, let's see what it says. There's my new password, capital P @SSW0RD. Look at that. Okay, so that's how easy it is to be able to detect what's happening on another box. If you're basically doing some really basic scans, this is clear text. Right? So clear text is something that really puts us in trouble. Now there is, of course, secure FTP. SFTP, which would prevent this from happening if you're using encryption and encrypted protocols. PuTTY sessions, for example, to be able to SSH into a box, you would not be able to see what's happening there. So some of the ways that you can see things and what clear text really means, and a really basic example of FTP sending clear text, and being able to see what Wireshark does and shows. Now the other awesome thing that I want to show you is the ability to be able to spoof an IP address. I'm going to show you how this is done in a very simplistic manner. I'm going to use a ping request. I'm going to ping my Linux box or my Windows box, and I'm going to capture that ping from Wireshark. I will then manipulate that packet and make it think that it is coming off of a different source and a different destination is going to, and a different MAC address and such. And I'm going to use a packet builder to be able to manipulate the packet and rebuild the packet. So let's see this in action. So I'm going to start Wireshark here. There we go. And here's my command box, my command button. I'm going to click on start. So the Wireshark starts its trace, and I'm going to do a ping 10.10.10.100. Okay, so there's a ping broadcast coming in. And if you'll notice, I'm going to stop this, and I'm going to save this. I'm going to do a save as, and I'm going to save this as a Wireshark TCP dump. I'm going to save this as ping 2. And I'm going to click save. Now notice I have a request reply. request reply. The reason I'm showing you this is because once I manipulate the packet, we're only going to have a bunch of replies. And the reason I'm telling you that is because if you were looking at and evaluating a packet and you only have a bunch of replies with no request originating from the right location, you do see a source and a destination, but you have a request reply combination. Okay? And when I expand this right over here, and right over here, you can take a look at the MAC addresses of where these things originated from. The source is 08002797D032, and the destination MAC address is listed right here. So I'm going to manipulate both of these things. Okay? And you see the ARP request right over here, just broadcasting out who has that address, and then it starts to reply. Now what I'm going to do is I'm going to open up this handy dandy packet builder, this Colosoft packet builder, and I'm going to import my ping2 that I stored. Right, let me change this, ping2, there it is. Okay, so look on the right hand side. Okay. Now the right hand side lists me the number of packets that went out, and on the left hand side it actually lets me manipulate every one of these packets. So I've got an ARP request over here. Destination is doing a broadcast, simply asking from this source, in this case my Windows 7 box, who has the address of 10.10.10.100. Packet size of 46 bytes. Then I have another ARP request with the destination to my Windows box coming from my Linux box that I have that address. And then I've got the pings. Okay? So what I want to do is I want to change this packet right over here. I don't care about the ARP requests in my particular instance, so I'm going to trash those. And I don't care about anything else that's going across. And the reason I'm saying that is because I'm going to manipulate this source here. So here's my source address right there, and I'm going to manipulate this. I'm going to say, for example, 00, 01, 02, 03, 04, 05. Okay, so there's my source MAC address that I manipulated, and my source IP address. Let me just put it in a different subnet, 192.168.1.102. How about that? So there's a source MAC address. Okay, I'm source IP address to the destination IP address, and I'm going to send an ICMP echo request right over here, okay, to 10.10.10.100. So how do I send this back on the wire? Very good question. Let me start a brand new trace, if you will, right there. I'm going to go back to the Colosoft, and I'm going to do a send all, and I'm going to specify that I'm going to send the packet 10 times. Okay, I'm going to send this one. The source should be 192.168.1.102, and the destination to be 10.10.10.100. I manipulated the MAC address, and I also manipulated the source IP address. I'm going to click Start, go to Wireshark, and look. See the source right here? 192.168.1.102. Okay. And you notice these are request. None of these are replies. And, you know, this would be a very easy indication that something's really bad happening. I've got source coming off, and notice right over here, look at the destination address. I'm sorry, the source MAC address, 00, 01, 02, 03, 04, 05. This would be the worst hacker in the world to label the MAC address like this and to set up a packet like this where it's doing just a request. The proper way to do this is to have a request and a reply, not just a request, and that to be able to intelligently build the packet instead of doing it in a very basic way here. Right? But I was able to rebuild the packet and manipulate it. So I'm going to stop this and go back over here, exit out of this, and minimize this, and close this, close that. Okay, so you got to see how the packet was sent out. An ICMP packet was sent out. I rebuilt it, sent it back out, and you were able to see the results of both of them in Wireshark.